Hello and welcome to further study of finding all solutions, or what's called the general solution, for some trig functions. Yesterday you dealt with the arc, cosine, and today we're going to develop similar equations for sine and tangent, arcsine and arctangent. This video will just deal with arcsine, and then you'll have to watch the arctangent video right after this. So both need to be done today. Basically, the general solution solved this very straightforward cosine of theta equals some ratio A, and what we got was this trig function arc cos is really just the inverse cos plus a bunch of periods, whether it's 360 or 2 pi. And because of some symmetry in this, we were able to use plus or minus in front of the cosine. That won't happen today with sine, but it'll be a similar format. Let's get back on track with what you did yesterday. You can undo, to find all angles in general and for a certain interval, you can undo cosine with arc cos. If you do it to one side, you do it to the other, the cosine cancels out. I get theta equals the arc cosine of the nice trig exact value ratio of 1/2. Well, where is cosine positive? Cosine's positive to the right. This being a 1/2 gives me a reference angle of 60 degrees, or as we learned yesterday, negative 60 degrees. So to use our formula, we can just say theta will equal plus or minus the inverse cosine. In this case, that's 60 degrees of 1/2. And then we can just add and subtract a bunch of 360s, and as a positive or negative integer. This would be our general solution. But they ask in this problem for all solutions from 0 to 720, so we use this general solution to generate a bunch of values that are in that interval. And 60 obviously is, if you add 360 to 60, you get 420. That works. If I add 360 again, I get beyond my interval. Now negative 60 doesn't work, this negative 60 here, but if I add 360 to that, I can get 300, and adding 360 again gives me 660, and that would be my answer for this problem. We're going to generate or do the derivation of where this formula looks for sine, and then also a tangent. Today's just in sine in this video though. Alright, so draw and label triangles for each, then find theta. In this case, for sine of theta, we want to know where is sine positive. It's positive above the x-axis, and its opposite is root 2 over 2, and you may recall that's a 45-degree angle. Now this angle is also a reference angle of 45, but it goes up from the left side of the x-axis, so it's 180 minus 45 for 135. And we want to use this 180 minus because we're going to find this inverse sine value of 45 in this case, or other values, and just do that angle and then also 180 minus that inverse sine value. So if we were to solve for theta with what we see here, we undo sine with inverse sine. If you do it to one side, you do it to the other. You cancel out and you get theta equals the inverse sine of root 2 over 2. And what that's saying is sine of one angle gives you root 2 over 2, and there's a lot of angles. In fact, there's an infinite amount, and we want to solve for that. So we would say that theta is going to equal the inverse sine, we determined to be 45 degrees, plus 360n, as well as 180 minus 45, plus 360n. And that's going to be the general way we write this. We, of course, know this is 135. So let's take a look here at what this looks like in general. We have the sine of theta equal to A. We undo it to find all values by this arcsine, which is simply the inverse sine plus 360, and then 180 minus because of the symmetry above and below the x-axis, the symmetry across the y-axis. And we can do this for radians or degrees. So this general solution is going to come in handy. I just want to show you real quickly that symmetry I talked about. It matters to understand that if we had a value for a trig exact value you wanted to get, and let's say the angle was 20 degrees, you could get a positive value for cosine if you go below the x-axis also, negative 20. And likewise, if let's say an answer was for cosine, the angle was 155, you could go negative 155 also. And that was the symmetry there for cosine from yesterday. Today when we dealt with sine, we saw asymmetry, but it was a little different. If I had an angle here that is, whatever, 15 degrees, I want to be 15 degrees above the x-axis, so that would be 180 minus 15 degrees. And similarly, if I had an angle down here, let's say negative 20, this angle over here, rather than trying to do some math specifically, we can just go 180 minus a negative 20. Minus a negative is plus. Sure enough, that's a 200 degree angle. So this 180 minus business, although it looks not quite as neat and clean as the arc cosine, it works, and it's going to allow us to create a shortcut for our formula. Let's look at a slightly more challenging problem, not incredibly difficult. For sine of theta, if we want to undo, we do arcsin on both sides if we want to find all solutions, and then we'll pin it down to the given interval once we get our little angle generator. So I get theta equals the arcsin of 1/2. And that's a nice trig exact ratio. We know that sine is positive and opposite of our angle above the x-axis. So from our little generator here, we get the inverse sine, which would be, in this case, 30 degrees. When we have the short side opposite, it's 30 degrees plus 360n. And then 180 minus 30 degrees plus 360n. And once you get familiar with this 180 minus and stop making the mistake of putting plus or minus in front, you don't need to put the 180 minus, but it's worth doing it a couple times just to make sure you remember that when you're doing sine. So our values that we want are theta equals 30. If we add 360, we get 390. If we add it again, we'd get beyond our 720. So let's go back to that 150. Adding 360, we get 510. So all solutions from 0 to 720 would be listed here. Let's try looking at a similar problem. It looks a little different, but really what's happened is we had the sine of theta was equal to 4/7. To undo sine, we arc sine, and when you arc sine, you get this problem. So it's kind of got one step taken care of for us. Some kids get a little confused by that. But now we're really one step in already. We can get to work. This one's going to be a calculator problem because 4/7 isn't one of our nice ratios. So using our formula, we're going to take the inverse sine of 4/7 plus 360n and 180 minus inverse sine of 4/7 plus 360n. And we don't have to redo all this work. We know this formula. We kind of proved it out. So let's find our values using a calculator. And we want to be in degree mode. So I'll verify I'm in the right mode. And I want the inverse sine of 4/7. I get 34.8. We'll just go to tenths in this case. So my general solution is 34.8 degrees plus 360n and 180 minus 34. I'm going to try to do that math in my head, I guess. 145.2 degrees plus 360n. Okay, that's our general solution. It's not on the given interval yet. So let's use this to generate our values. Theta will equal obviously the 34.8. If we added 360 to that, we'd get 394.8. As well, the 145.2, add 360, we'd get 505. And there's our answer. Why don't you give this one a try, see how it goes. Remember, now you're in radians, and you're going from negative 2 pi up to positive 2 pi. So here you might end up subtracting your period of 2 pi to get some of the answers. Give that a try, hit pause, and we'll come back and finish it up. Okay, hopefully you were able to get the problem answered or found a situation where you're not sure what to do, and we can fill in some blanks for you. All right, well, we're already set up to just write our general solution, the inverse sine of negative 2/3 plus, in this case, 2 pi n, and pi minus the inverse sine of negative 2/3 plus 2 pi n. Remember that it's not 180 degrees. It's pi radians, same distance, just different units of measure. So we're going to take our calculator again and find our inverse sine of negative 2/3. Oh, but we got to make sure we're in that radian mode. And we get negative 0.73, we'll go with. So plus 2 pi n. And then pi minus 0.73. Second caret gives us pi minus our previous answer, second negative. Gives us a 3.9. Now, those numbers don't look very familiar probably. Let's just take a quick look here. Remember now, this is pi, or 3.14. So negative 0.73 would be a value down here somewhere, about a third of the way. Yeah, so it's about a third of the way. It's going to be more in this area. And then 3.9 is going to be just beyond there. So we see some symmetry here that has a similar reference angle. So looks reasonable. Now let's generate values from negative 2 pi to positive 2 pi, and we get x equals negative 0.73, and if I add 2 pi, not that thing. I get 5.6, we'll call it. And then I'll have this 3.9 plus 2 pi. This is not working. 10.2. So 3.9, 10.2, and then I've already forgotten my previous value. .6. So there's my answers in radians. Here are some on your owns to try. We got a trig exact value and a calculator problem. Make sure you notice that if it's theta, you're in degrees, and x is radians. We'll see you in class. Make sure to watch the arcsin video as well.